is that with 10.4, you're looking at addition and subtraction of radicals. Okay, and here's basically what it is. With 10.4, there's, I guess, two big things you're looking at. The radicand, which the radicand is the number that's on the inside. When you're going to do addition and subtraction, the radicand must be the same in, say, both terms. So they give you one that's square root of 3 and the other one's square root of 5, and they ask you to add it together. You can't do it. Both of them have to be square root of 3s when you break that down. So once you've got the square roots the same, where the radicand's the same, the inside numbers are the same, the second thing you're going to do is you're just going to add or subtract whatever the sign may be that they ask you to do. You're going to add or subtract the coefficient. And again, the coefficients are just the numbers that's in front of x. Okay, here's kind of the one big thing that you have to be careful of. The radicands, the number that's on the inside, they don't change. Okay, so let's give you a couple of these just to make sure you kind of understand what's going on. And it's kind of baby steps. They'll give you a few of these to kind of walk you through, give you some numbers, and then they'll start slowly changing some things up where you have to do a little bit more work with it. But, okay, so let's say you've got 4 square root of 3 plus 5 square root of 3. Okay, first thing is radicands are the same. They're both square root of 3s. So then what you're going to do is you're going to take whatever the numbers are in front, and it's almost like a separate problem. You're going to do 4 plus 5, and then the square root of 3 is just kind of behind it there. It's basically like doing 4x plus 5x. You know, if you did 4x plus 5x, that would be 9x. This one's the same thing, but now it's almost like when you have your square roots, those are like x's. As long as it's the same number, it's almost like it's its own variable when you're going through those. So you do 4 plus 5, that would be 9. The square root of 3 doesn't change, so that answer would just be a 9 square root of 3. Okay, so let's do square root of 13 plus 5 square root of 13. Okay, again, your radicals are the same. You got square root of 13, square root of 13. The only thing you have to kind of realize is that when you're doing this one, that is a 1, because there's a square root of 13 that's there. That's almost like 1 square root of 13. So then you can do 1 plus 5 and make that 6 square root of 13. So if you run across one of the square roots that doesn't have a number in front, just go back and put a 1 there. Just like if you were doing, again, if you want to think about it, this is almost like you're doing x plus 5x. Well, if you were adding that together, you have to understand that there's an understood 1 that's with that x. So then it's 1x plus 5x, which would make it 6x. Square roots, it's almost like the same thing, that the square root is like a variable. It's its own separate little thing. That if you had this one was square root of 13 and this one was square root of 14. Well, it's almost like this one's an x, that one's different, so it's like a y. Can you add an x and a y together? You can't, can you? Same thing with this one. If those are different square roots, you can't add them together. So they have to be the same square roots. And once they're the same square roots, you just add or subtract the numbers that's in front. So it's 5 square root of 3 minus 7 square root of 3. Well, you just do 5 minus 7. And then the square root of 3 is just going to hang out the end. 5 minus 7 is negative 2. Okay, so that's pretty straightforward. Square roots are the same. Add or subtract numbers in front. Oh, that should have been number 3, right? Bad when your math teacher can't count. Okay, once they've got you confident and simple there, they're going to tell you it's just square root of addition or subtraction. And they actually give you 2 different numbers to start off with. So we're going to have square root of 5 plus square root of 20. Okay, and the big thing on this one is when your numbers are different, you don't just put, no, we can't do it, we're done. No, this is one where they want you to break. You actually have to do something to it first. So if the radicands are different, you're going to have to break down. And then you're going to have to simplify each one. And normally if you do that, then you should finish where that both of these numbers, when we take the square root of 20 and break it down, we take the square root of 45 and break it down. Once you take those 2 numbers and break it down, you should have the same numbers inside the radicand, and then you can add or subtract the numbers that's in front. So when the radicands are different, break down the radicands to simplify each one. The radicands should be the same. So that then you can either add or subtract depending on whatever the signs are. Okay, so with square root of 45, start breaking it down. And again, first thing I'm thinking of, it's 9 times 5 because we can do the square root of 9. That's going to make it 3 square root of 5. And again, most of the time, if you know that this one was left with square root of 5, you probably want to do 5 times something to break down the rest of the other one here. If you take 20, break it down, it's 4 times 5. Square root of 4 is 2. So I'll leave you with 2 square root of 5. Now you've got the same radicands, where you've got square root of 5 and square root of 5. Now you can take the whole numbers, do 3 plus 2, and that would make it 5 square root of 5. for the second one, let's do 2 squared of 32. We haven't done anything where you've already got a number out front, so let's throw that one at you, because it should start to bring you some in like this. We've got 2 squared of 32 plus the square root of 8. Yeah, so breaking down to 32, that is 16 times 2. And if you want to put the 2 out front, just go ahead and leave the 2 out front. When you do the square root of 16, that is a 4. And then you're left with the square root of 2. Since the 2 is already out front, it's still 2 times that entire thing, so you've got 2 times 4. So that's really an 8 square root of 2. Alright, if you take the 8 and break it down, it's 4 times 2, and then the square root of 4 is 2. So, taking the first number, breaking it down with the 2 that's in front, that's 8 square root of 2 plus 2 square root of 2. Do the 8 plus 2, so that makes it 10 square root of 2. Okay, let's do 1, 1. Let's do square root of 63 minus 2 square root of 28. Alright, with 63, if you start breaking it down, that is 9 times 7. And again, with 9 being a perfect square root, that's really 3 square root of 7. And again, if that one's square root of 7, there's kind of your hint that, alright, we're probably going to do 7 times something with the 28. So we've got minus the 2. If you take the 28 and break it down, that would be, what, 4 times 7? Because we know we need the 7 in there. Square root of 4 is 2. We had the minus 2 that was here, and that's still 2 times that. And it's almost one of those where if you've got 2 squared root of 28, you can almost put a dot there, because you know you're going to do 2 times there. So you've got the 2 times 2 to make that 4. So you've got 3 squared root of 7 minus 4, so if you do 3 minus 4, that's negative 1. And if you have negative 1 square root of 7, again, you don't have to put the 1, so really that's just negative square root of 7. Okay, so if they give you 2 terms, unless it's a trick question that I don't know that they're going to do that to you yet, when you break these down, it should be that both of the roots when you get there should be the same, so that you can just take whatever numbers you have in front, add them or subtract them together. Okay, where that it might change just a little bit is when you have 3 terms. Because when we're doing the 3 terms, it may be that all 3 have the same radical with it. It may be that 2 of the radicals are the same and one of them's different. You really don't know until you take the numbers and just break them down and see what you get. So you have square root of 12 plus square root of 48 plus square root of 3. So you really don't know. I mean, it could be that you may get one answer at the end. It may be that you may have 2 terms at the end. You don't know until you get there. It's like Christmas. It's a surprise, right? Well, not as good a surprise as Christmas. So, okay, 12. Again, this one's square root of 3 at the end, so kind of giving you a hint that maybe we can try 3, see what we can get out of it. With 12, that is 4 times 3. Square root of 4 is a perfect number, so that's 2 square root of 3. Okay, with 48. Again, let's go ahead and try the 3. 16 times 3. Square root of 16 is 4. And again, you already had the square root of 3 that was here. The only thing I would say with that square root of 3 when you bring it down, and here's where sometimes it's easy to let slip by. There is 1 square root of 3 that's there, so don't forget to put a 1 with that one. So when you bring it all back to the end, it's really 2 plus 4 plus 1, and then you're going to do the square root of 3 of all those. So it'll make it 7 square root of 3. Okay, let's give you another one of those. Let's go square root of 28 plus 2 square root of 63 and minus 12 square root of 7. Okay, and here's the hint on this one. 7 is your prime number. This one's broken down as far as it can go, so let's take a 7 out. Let's see what we can do with these. So let's see if they're all square roots of 7. With 28, that would be 4 times 7. And you can do the square root of 4 and make that 2, so that would be 2 square root of 7. With a 63, that's 9 times 7. Now again, you had the 2 that was in front, so don't forget about the other. And again, if it helps on that one, just go ahead and do 2 times the 9 times the 7. You've got plus 2. When you square root 9, that is 3. So for that one, they all came out to have the square root of 7. So we've got 2 square root of 7. Doing 2 times 3, that's a 6 square root of 7. At the end, you've got a minus 12 square root of 7. So really it's 2 plus 6 minus 12. So that's 8 minus 12, that's a negative 4 square root of 7. Okay, now the examples I'm looking at when I'm scrolling through here, they all wind up being the same. Let me give you one that's different, just in case you do happen to get one. Because there's pretty good, I know none of the problems I've got that are popping up are this way, but there's a good chance that somebody's going to see one like this. Let's just make sure that you've seen one. Okay, let's go square root of 45 plus 3 square root of 20 and minus 17 square root of 6. All right, with 45, that's 9 times 5, and with the square root of 9, you can make that part 3. When you take 20, break it apart, that's 4 times 5. Square root of 4 would be 2. Left with the square root of 5. So we have 3 times 2 square root of 5. And with 16, with the 6, you could break it down and make it 2 times 3, but it doesn't really break down any farther. So for that part, it's just 17 square root of 6. Okay, so we've got 3 square root of 5 with this one. We've got 3 times 2 for 6 square root of 5, and then minus 17 square root of 6. Okay, so when this one's different than the other two, the only ones you can add or subtract would be those two. So 3 plus 6 would be a 9 square root of 5. And since this one's different at the end, there's nothing you can do with it. It just hangs out at the end there. So that would be the answer that you're looking for. So if one's a square root of 5 and the other's a square root of 6, you can't add those together. They have to say it's two separate terms when you try to put that part together. And again, all the problems I'm looking at, they all come out to be the same, but somebody in there is probably going to get one where that they don't work out to be the same. All right, and then the last objective you've got in 10.4. you're going to simplify a sum or difference of radical expressions. So up until that point, it's the exact same thing we were doing, but here's where they take on one little word at the end, which makes it all change different. They're going to say it's a univariate, which means if you've got a univariate, you got the vary part in here, which that means if you got a variate, that means you got a variable, which means you're going to do letters. So let's go with this. Let's go square root of 12 x to the 5th plus 2x square root of 48x to the 3rd. Okay, and it's still the same thing as the first part. You've got to take these square roots you've got, and everything up to this point is all square roots. They're not doing any third roots or fourth roots. Take the square roots you've got and break them down as much as you can. Because you've got the 12 and the x to the 5th, you've got to think that's the square root of 12 and it's the square root of x to the 5th. You're going to take that one term you've got and simplify both parts and put it all back together. If you do square root of 12, you could do 6 times 2, but if you do 4 times 3, square root of 4, you've got a perfect square root, so make it 2 square root of 3. With x to the 5th, you're going to take 2 and divide it into 5. Because that would be, I need that one more step in the middle here. That's going to make it x to the 5 divided by 2. So when we take 2 and divide it into 5, we're going to have 2 on the outside and 1 on the inside. Okay, so we've got the 2 that's on the outside here. We're also going to have 2 x's on the outside. On the inside, you're going to have a square root of 3, and then you're also going to have 1x. So this one goes on the outside, this stays on the inside. Okay, so there's your first term simplified and broken down as much as you possibly can. Then you've got the plus. Well, now you're going to do the same thing on the second term back here. You've already got the 2x. You're going to have to do the square root of 48. And then you're going to have to do the square root of x to the 3rd. Just kind of put that in here so it kind of stays through the middle. That way we kind of separate the two. All right, 2x is good. With the square root of 48, again, you could do 2 times 24. This one's already got a square root of 3, so they're kind of giving you a hint that, okay, if this one's square root of 3, let's try square root of 3 with this one. If you divide that by 3, that's 16 times 3. So this one you can take a 4 out. So really this is an 8x square root of 3. Because you got 2x times 4, so we're making that 8x here. The x to the 3rd, well, now you're going to take 3 divided by 2. So we divide 2 into 3, that's going to go one time with 1 left over. So we've got 1x that's going to go on the outside and 1x that's going to go on the inside. Okay, so let's put all that together here. You've got the 8x. Now we're going to put one more. We already had 8x. We're going to put one more on the outside. So if we put one more on the outside, now we've got 2x's on the outside. We've got the square root of 3, and we're also going to have one more x on the inside. Okay, so the second one was a little bit tricky because you already had 8x, but now you're going to put one more on the outside. And since we already had the 1 here, when we put the 1 more, now we've got x squared. Now you've got the same square roots. You've got square root of 3x and you've got square root of 3x. So now you can add these two numbers. So that's really 2x squared plus 8x squared. And the square root of 3x. So if you do 2 plus 8, that is 10x squared. Okay. And then the biggest thing is when you're adding and subtracting, you don't change anything with the exponent powers, whether that's the number on the inside or the number on the outside. If you're doing x squared plus x squared, it stays x squared. You just add or subtract the whole numbers. No. This is like a regular test. This is an hour and 25 minutes. The 5th test is the one that's the short test, because we only cover there's really 3 topics there, and they're all kind of interrelated. So this is just like a regular test for this one. All right, let's give you another one of those, because those are so much fun, right? All right, so let's go with a 5x. Okay, let's go 5x squared of 32x to the 3rd, and then 8x to the 5th. And actually, I'm running out of room. This is right at the bottom of the page. Let me go ahead and add that on the next page. Okay, so again, we'll do this with the plus here. And again, with the plus, it's almost separating this into 2 parts. You've got to take the first part, break it down, take the second term, break it down, and then see what you've got. And they should be, for everything we're looking at this one, they should be the same when you get finished with it, so you can actually go back and add these together. When they give you these with as much stuff as going on, you should be able to add and subtract these together. They won't make these different. Okay, so really it's all back here. 32. A bunch of different ways you can break it down. If you start just breaking it down because it's even, if you do 16 times 2, hopefully that 16 times 2 jumps out at you, because you knew the square root of 16, make that 4, square root of 2. The 5x was in front, so it's really 5 times x times 4. So really this thing would be 20x square root of 2. All right, with the x to the 3rd, that one you're doing 3 divided by 2. 3 divided by 2 into 3, that'll go 1 time with 1 left over. So again, you're going to have 1 more x on the outside and 1 x that's going to be left over on the inside. And since you move this 1 that's on the outside, there's already an x on the outside here. So kind of the same thing here. You're going to have 20 x squared. We've got the square root of 2, but you're also going to have 1 more x that's on the inside. Okay, now, the second one's actually going to be a little bit easier because it doesn't have all the stuff that's in front. If you do square root of 8, well, that's 4 times 2. Square root of 4 is 2. So that's 2 square root of 2. We do the square root of x to the 5th. You're just going to divide 2 into 5. 2 going to 5 2 times with 1 left over. So we're going to have 2 x's on the outside and then 1 x that's going to be left over on the inside. So this one is 2. Again, we're going to have 2 x's on the outside. We've got the square root of 2, and then we're also going to have 1 more x on the inside. Okay. And again, for these problems, it should be that you've got the same square root, so now you can just add or subtract the numbers in front. So it's 20x squared plus 2x squared. Square root of 2x. And it's 20 plus 2, so that would make it 22 x squared, and then put the square root of 2x behind it. Okay. And I think the worst thing on these problems are when they give you this extra stuff that's in front of your radical, that's the part that makes it more complicated, because usually one of the terms, and the problems I've looked at so far on all these, they give you one that's a fairly easy one to break down, one that's got a little bit more stuff in it. This one by itself is not too bad. It's this one sometimes that kind of gets to be a little bit difficult, just because there's a lot of stuff going on there.